For centuries, people have used codes and ciphers to protect secrets. Ancient methods like the Caesar cipher shifted letters to hide messages. These early techniques were simple, but they laid the groundwork for modern cryptography. Modern cryptography is far more complex, relying on mathematical algorithms. Public key cryptography, invented in the 1970s, revolutionized the field. This system uses two keys, one public for encryption and one private for decryption. RSA, named after its inventors, is a widely used public key algorithm. Quantum computers, with their immense processing power, pose a new threat. These computers could break many of the cryptographic algorithms we rely on today. Post-quantum cryptography, or PQC, aims to develop algorithms resistant to quantum attacks. PQC is crucial for ensuring the long-term security of our data and communications. The future of cryptography is full of exciting possibilities and challenges. New technologies like homomorphic encryption will allow computations on encrypted data. Lightweight cryptography will become essential for securing the Internet of Things, or IoT. The development of new cryptographic techniques will be crucial in a world increasingly reliant on data security. The demand for cryptography experts is soaring, driven by the growing need for data security. Skilled cryptographers are needed in various sectors, including finance, tech, and government. Job roles range from security analysts to cryptography engineers and consultants. Salaries in the field are highly competitive, reflecting the importance and specialization of the work. A career in cryptography requires a strong foundation in mathematics and computer science. A bachelor's degree in a relevant field is typically the minimum requirement for entry-level positions. Advanced degrees, such as a master's or PhD, can open doors to research and specialization opportunities. Online courses, workshops, and certifications can provide valuable knowledge and skills. Cryptography is fundamental to our digital world, protecting our privacy and securing our data. As technology advances, so too will the challenges and opportunities in cryptography. By understanding its history, embracing new innovations, and nurturing skilled professionals, we can ensure a future where our secrets remain safe.